Welcome to the third video in my FPS character controller tutorial series playlist. The playlist and the GitHub link will be down below in the description. And in this video, we're going to be tackling stair handling. So by default, you'll just get stuck if you try to walk on stairs or even small objects. Because the character body 3D is just a capsule or other shapes sliding along the floor, it doesn't by default have any programming in for stairs. You'll also run into some trouble going downstairs and you'll just fly off of them. You can sometimes fix this by using ramps, but even this isn't foolproof, and on ramps sometimes I find myself getting stuck with the default capsule character body 3D. So in this video I'll show you the cleanest method that I have found to handle smoothly gliding upstairs. First, I'll show a really quick fix that might work for you. I'm not going to recommend it, but it might be good for some people. If you add a collision shape 3D to your character, you can use a separation ray shape. And you'll see if you kind of rotate it and point it down right in front of your character, this gives you a ray that is going to push the character upstairs. And now if that's all you needed, you're done. You can go upstairs now. But as you can see, it's really not smooth at all. It's really jittery. And also, you still have the problem of going downstairs and just flying off the top. And also it introduces another problem. You can now walk on surfaces of any steepness. Your character's max floor angle is not going to be respected. So for these reasons, we are not going to be using the separation ray shape 3D method in front of our character. Instead, we will be using a method that adds a few functions and two raycast 3Ds to our character to smoothly move us up and down the stairs. By the way, if you want to know how I made these stairs, it's using this CSG StairMaker 3D scene I made. If you're following the FPS tutorial from the start, you should already have this from the starter project in the utils folder. If not, I'll include it in a link in the description. It's just a CSG box 3D with a CSG polygon 3D that carves out the stair shape in it. So if you use it to make a new stair set and you want to walk up it, make sure to check the used collision box on the right there too. So to get started with the method we're going to be using today, I'm going to add two raycast 3Ds to my character body 3D. I'm going to call one of them stairs ahead raycast 3D, and I'm going to call the other one stairs below raycast 3D. I'm going to right click both of them and select access as unique name, which lets us access them with the % in code. For this stairs ahead raycast 3D, it's not super important where exactly it's positioned, but make sure its length is slightly longer than your max step height. We're going to reposition it in code later. And make sure it's pointing down, so the Y should be negative. For the stairs below raycast 3D, which is going to detect when we have a stair to step down to, I'm going to set its length to negative 0.75. It's important to have it a bit longer than your maximum step height to prevent any glitchiness. And it should be at the base of your character 3D pointing directly down. Make sure not to get the up and down directions of the raycast mixed up. The visual in editor is not super clear. So notice when you select a raycast 3D, it'll have like a gizmo, rotation and translation gizmo at its origin. And it's subtle, but the direction it's going in, it kind of comes to a point. Both of these need to be pointing directly down for this to work. So both of their target positions should be negative. My step height is going to be 0.5, so I have my raycast set to length negative 0.55 and negative 0.75. For both walking up and down the stairs, we're going to use a method from the Physics Server 3D, which is a singleton that you can access from any script. And this allows you to interface directly with the physics engine in Godot. We're going to use the body test motion function, which, just like it says, it allows you to test a motion on a body. So it lets you run a simulation of moving that body without actually having to move it. So basically what the body test motion function is going to do, if we have our player walking, and then he walks off the top of the stairs and he maybe flies off like he currently will, and we want him to slide down, so we'll send a body test motion, and that lets us send a duplicate player down and see if he would collide with anything if he did move down there without actually having to move down. And it'll give us the exact point of collision wherever the first point of collision was that he hit. So now getting into the actual code, let's implement the two functions that we're going to need to use as utilities for this. The first of which is going to be this is surface to steep function, and if you followed the previous tutorials, you already have this function. I did simplify it a little bit, but it functions exactly the same. You can update it to be exactly like this if you want, but it shouldn't matter because it functions the same. And yeah, just like the name says, we're going to use this to check if the stairs or floor we're snapping down on is not too steep, because the character body 3D has this floor max angle variable defined by default, and it should be 45 degrees by default, I think, but you can modify it on your own to whatever you want. Mine is set to 45 degrees. And what we're going to do is check if the normal, which is the surface normal, and remember what a normal is. All physics surfaces have a normal, and it's just a vector pointing directly out of it. So a floor normal would be pointing directly up. If it was a wall, it would be directly sideways. And if it was like a ramp, it would be somewhere in between. And so yeah, we'll just be passing in the collision surface normal of the floor or whatever we're going to be colliding with. And then we're going to check if its angle to up is greater than the max floor angle. And if the angle of the floor is greater than the max floor angle, then the surface is too steep. And this coincides with the default behavior of the character body. Whatever you change this to, your character will not be able to walk on surfaces more steep than that. Next function we're going to define here is called run body test motion. It takes three parameters: the from, the motion, and the result. And the result is going to be an optional parameter here. We need to pass this into the physics server either way. But if we don't want information back on the collision, we'll just define like a dummy one. And we don't have to pass it in here because we're going to be reusing this function a bunch of times. And then we will define the parameters object, which the physics server 3D uses. And we'll need to set the from and the motion parameters on it. The from is going to be where we're running the position or the initial position of the body test motion. So usually we would use the current position of the player object, but we can also do it from anywhere. And then the motion, this is going to be like directly down, looking for the stairs below us. And then finally, we'll run the physics server 3D body test motion call and return the result from this function. And here we're doing the self.get_RID function. And this allows us to get the underlying resource ID for the physics object so that the physics server 3D can identify it. This is basically just what the physics server will know our character body as. And then we'll pass in the params and result parameters as well. And a useful thing to know, if you ever want to know more about a function that you're using in Godot in code, you can always open up the docs in the Godot editor by right-clicking on the function or class and doing a lookup symbol. And if it's a built-in one in Godot, it should bring up the docs for you. And so here, we're going to be using this body test motion result, actually. So if you scroll down to the docs here and look at the get travel function, you'll see it says it returns the moving object's travel before collision. So this will be important here. This is really nice to have because we know that if it returns true and it collides, we'll be able to get the exact position right before a collision, aka a safe position to move the character body 3D to where it won't get stuck. So we'll be moving them basically right directly above the floor, but they're not going to clip into anything and get stuck in anything. All right, so back in the code here, we're going to define a couple more variables. So I'm going to scroll up to the top of my code here, and we're going to add 3 variables. The first one is going to be the max step height. Mine is 0.5. If you want to copy it, probably good for while you're following the tutorial, just trying to get it working first. The next will be the snap to stairs last frame variable. And this is just going to keep track of whether we snapped to the stairs, obviously. And the final variable is going to be the last frame was on floor. And I'm setting this to -infinity because I'm not going to assume that we're on the floor starting off. So this will basically be equivalent to the last frame we were on the floor like doesn't exist. It's -infinity. And we're going to be setting the last frame was on floor in the physics process function. So let's go do that. And I'm just going to set it at the very top of my function here. So if we're on the floor, then we set the last frame we're on the floor to this function, which gets us like the frame number. So this is going to return an integer. So like the first term will be 1, 2, 3, 4, 5. It's going to count up to like 50 billion or like however many frames you have in your game. So we just have like a running counter of which frame number we're on. And so we'll be able to see if we were on the floor this frame, last frame, or how many frames it's been since we were on the floor. And so with that, we have everything we need to implement our snap down to stairs check function. So I'm going to put mine above my no clip function I already have here. And I'm going to call it snap down to stairs check. And I'm going to set the variable did snap to false at first. And then set this variable was on floor last frame, and using the last frame was on floor, we're setting on the physics process. And what we're looking for is the exact frame prior that we were on the floor. So like we're going to snap down to the stairs if it's the frame right after we fly off the top of the stair set to get that behavior where we glide down it. And then I'm going to set up this if statement here. So we only want to snap down to the stairs under these conditions. So obviously we don't want to be on the floor, and we want the velocity.y to be negative. So this would mean we obviously only want to snap down when we're moving downward. So like not when we are jumping. And then we're going to check whether we were on the floor last frame or we snapped down to the stairs last frame. And the reason we have this snap down to stairs last frame variable is because even though we snap down to the stairs, it doesn't always register as being on floor. So we need to keep track of when we're snapping the player down to the stairs. So after we do that if statement, we are going to do this, set up this body test result variable. And then we're going to use the run body test motion function that we set up before. And just a real quick review, what we're doing here, we are passing in the body's current global transform, because all the physics server uses global coordinates for everything, by the way. So we're passing in the current global transform as the start position of the test motion, and then we're shooting it down the maximum step height. So hopefully that makes sense. We only want them to be able to step down that high. And then we will pass in this body test result variable because we want to get the information back from the collision. And then we're going to use that information right here and get the translate y. So if this collision or this test motion succeeded, which means we found a stair below us, then we're able to get this get travel.y variable, and that is going to get us the exact collision point right before we hit the stair. So this will be a y position that we can translate the player by to land them perfectly right on top of the floor, and they're not going to be colliding into anything, getting stuck. So then we will just add their y position by the translate underscore y variable and apply floor snap. And this just tries to make sure that they get snapped to the is on floor state, because even though we moved them, it might not have been updated. They were probably floating in the air right before we moved their y position. So if they're like right above the floor already, this will just put them into the on floor state. It's also possible that they hit like the lip or the edge of the stair, so they can't get put into the on floor state, but that is what the snap to stairs last frame is for. So we try to make sure they're on the floor. That might not happen, so we set this did snap variable to true, and using that we'll set the snapped to stairs last frame variable to true if we just snap them. Otherwise it will be set to false, so they won't be snapped to stairs last frame if we didn't do it here. And now that's all we need in our snap down to stairs check for now. And I'm going to scroll down to my physics process, and I'm going to call the snap down to stairs check right after the move and slide. And the reason I'm calling it right after is because this is going to be like right after it flies off the stairs and before it's actually rendered. So if we called it before, it's possible that it might be less smooth looking, or it might even glitch out a little bit. So I'm calling mine directly after the move and slide to make sure it works. And now if you test this snap down to stairs check function, you should see that it works just fine. We can snap down to stairs, and it might look a little bit jittery right now, but we'll fix that a little bit later. but we have a basic idea of what we want to do for snapping down the stairs. Now you'll notice perhaps that we did not use that stairs below raycast. So what's this for? Well, if you notice, if you walk off things that aren't stairs, your character is doing the same snap effect as if it was walking down a stair. So it makes sense why he's doing this. Like the frame right after he flies off the stair here, like he's gonna be basically right here, and it's gonna shoot a body test motion down because we're not on the floor anymore, and it is going to collide with his butt right there on the edge of the platform. Even though the body test motion hits something, it's not a stair and it's not something we want to snap down to in this case. So this is what we're going to use the stairs below raycast for. The frame right before it snaps down, we are going to make sure we're actually snapping down to stairs below us. So we're going to use that raycast that points down here and shoot it down directly below, and if we're stepping off into like nothingness, it's going to not hit, and we know not to step down the stairs. Whereas if we did it over here and he walked off here, it would hit these stairs right here, so we would have stairs to snap down, we would know. And now what's this actually going to look like in code? Well, in our snap down to stairs check function, we're going to add a variable floor underscore below, and it's going to be a boolean, which we will set to true if the stairs below raycast 3D is colliding, and if not, the surface is too steep. So if the surface is not too steep and the surface we're passing in is the surface normal of whatever the raycast 3D collided with. And then that will allow us to check if there is a walkable floor that's not too steep below us. And we'll just add and floor below to our if statement here. And that will prevent the edge case of us just walking off into nothingness and still snapping down. And if you try this, it's no longer going to have that sharp jitter when you walk off of platforms, but you'll still be able to use these stairs just fine. Might jitter a little bit, but that's just because of the shape of the capsule. And now for walking up the stairs, it's going to be a pretty similar concept. We're going to have our player approaching here, and then instead of shooting a body test motion down like before, we're going to run one slightly in front and then down. So we're going to like have a body test motion start basically like right here. So it's going to be above and in front of the player, and then we're going to shoot it down from there. So here it would be like probably something like this. And then from this spot in front of the player, we're going to shoot it down and see where it hits and use the same concept. And as long as the body test motion ends up colliding at their feet and we're not teleporting them above the max step height, we can still take advantage of that idea of having a safe place to teleport them to by checking the travel distance and making sure we teleport them right before we hit something on the body test motion's path. All right, and now what will that actually look like in code? As a reminder, before I start here, all the code is going to be available in the description on GitHub. It's CC0 license, public domain. You can copy it, use it for whatever you want. You don't need to credit me because this function is going to be a little more complicated, so I don't blame you if you choose to just copy this one. I tried to record this a couple times, but it just ended up me talking for like a very long time. So I'm going to more quickly run through this. We are only going to run the snap upstairs check function if we are on the floor or snapped up to stairs last frame, which would also be on the floor. And then we get the expected move motion, so velocity, X and Z components only, times the delta. So this would be like what the physics engine does already. So like the velocity times the time equals the position we're expected to move. And then we're doing this moving the, or this is going to be the body test motion start pose. So the global transform of the player translated forward and slightly up. So we're doing ×2 because it's going to be the forward motion plus some clearance above the player so they can't step into something if there is like something blocking their head there. Then we get this down check result with a physics motion test result, very similar to what we did before. And we're running a body test motion from that step pose with clearance. And we only want to allow the player to step onto stairs if they're static bodies, and CSG Shape 3D that would also be a static body. That's when you use like CSG Box or whatever and click Use Collision in Editor. So if indeed the player's body test motion down towards the stairs hit and the collider was a static body, then we're going to get the step height. And that would be we're basically checking the exact hit point and subtracting the current global position. So that would be like, how much higher up would we have to translate the player on the y-axis to get to wherever it hit. And here we're going to make sure the step height is not greater than the max step height. And we're also going to make sure it's not like really low, because I noticed it caused jitter. Like you wouldn't even need to use this to step up to this height. And this part makes sure the collision is happening at the feet and not like too high up on the character, where it wouldn't make sense to teleport them up to that part. And then this is where the stairs ahead raycast comes in. We can't use the collision normal of just like the body test motion, because the capsule is not always going to give us an accurate collision normal with like a stair, because it might hit like the front of it. So we're setting the stairs ahead raycast 3D to the expected position. So we're going to place the raycast 3D at the position of the collision point plus the step height. And then we move it slightly forward towards where we're moving. And then assumedly that would hit on like the flat part of the stairs. And force raycast update, after you move a raycast, it doesn't update till the next frame unless you call this function. Finally, we just check if the raycast is colliding and make sure the surface it's colliding with is not too steep. So it's a floor or stair we can step up onto. And then we set the player's global position to the resulting position of the body test motion. So that would be the start position of the body test motion plus the travel wherever it hit. And apply floor snap just like before. Set snap to stairs if we did indeed snap, because we just did. Return true if we snapped, and return false otherwise. And that is all done. And now in the physics process, we're going to call the snap up to stairs check. Notice I wrapped the move and slide in the snap up to stairs check. That is because we just manually moved the global position of the character. So if you called move and slide, it would like move the velocity, like we're already moving by the velocity because we're running a body test motion above and in front of the character. So I don't call move and slide after snapping up the stairs. And nor would I call snap down the stairs, because we already snapped up. There would be no reason to snap back down. And while we're here, one more thing I would suggest that you add is any type of logic where you're checking if the player's on the floor. I would add an or snap to stairs last frame, because we basically want to count that as being on the floor, because rightfully they should be on the floor, but it's possible that they got snapped down to like the lip or the edge of the stair, which wouldn't technically is on floor. So I'm adding this, and this will make sure they can jump while they're running down the stairs. Without this, sometimes like the jump won't go through if they press it and they're like on a weird spot in the stairs. And with that, we are all done. Walking upstairs should work just fine, and we got walking down them in there too. And now the only thing really left is smoothing. So for the smoothing, we're just gonna do like a camera smooth. It's hard enough to get like perfect physics walking up and down the stairs, so adding in smoothing to the physics, that would be, I think, way too much. And to do this, we're basically just going to have the camera pivot around a node and like slightly lag behind the Y position so it doesn't jitter too quickly to its new position. And for the camera smoothing, the setup of your head node is going to be important. So notice how my camera is here. The position's at 0, 0, 0. The head is the thing that's moved. So I have my head at 1.79, but my camera's at 0, 0, 0. This is vital because it allows the camera and the camera smoothing node that we're about to add to pivot around the head and always drift back to 0, 0, 0 easily. I already have head bob going on my camera, so I'm going to add another separate node to pivot the camera around again, called camera smooth. And basically the camera's position will still stay at 0, 0, 0 in this node, but the camera smooth node will glide around to prevent any jitters going up and down the stairs. I'll enable a unique name for the camera smooth node and then make the camera 3D a child of the camera smooth node. And so to get some really nice camera smoothing in here, we can get that going pretty quickly with just a couple of functions. I'm going to set this variable save camera global pose to null to start. And then we'll set that variable in the save camera pose for smoothing function. This will save the global position of the camera or camera smooth node for what it is before we snap to the stairs. So it will be able to like lag behind the player's head pose in whatever direction they're moving. And then in this function here, slide camera smooth back to origin, here's where we'll actually do the smoothing. So if we saved the camera global pose, we'll do this function. Otherwise, we'll just return. And we'll set the camera smooth's global position .y to whatever it was saved to. So this is basically going to make the camera move independently on just the y-axis. And this will allow it to like lag behind when the player's walking down the stairs or up the stairs. And then we want to clamp the position.y to make sure it doesn't go further than negative 0.7 or 0.7 because it's possible the player teleports or something else. And in that case, the camera's position.y, the global position would get like way far away, and we don't want the camera smooth to like go way far out of our character. We're just smoothing it a small amount, so negative 0.7 and 0.7 is what I'm setting mine to. And then next we just calculate the move amount, and here we're just moving based on the current velocity, so like however fast we're moving down the steps or forward. We'll use that to smooth the camera by that speed as well. And then we want to make sure, because like if the player stops like on the steps and their velocity happens to go to 0, we don't want it to stop the smoothing completely. So at a minimum, it should be their walk speed divided by 2 multiplied by delta. And then we'll use that to just move the camera's position.y with the move toward built-in GD script function towards 0. So we're moving the camera's position.y towards 0 by the move amount. I think it's pretty clear. And after we move it, the position.y, we're going to save the new camera's global position for the next frame here as we continue smoothly interpolating it back. And if the position.y has reached 0, that means we're back at the origin. We can stop smoothing the camera. And that is all we need to get a really nice camera smooth function going. And we'll call this in our snap down to stairs check function right before we set the new Y position of the player. So it's going to save that camera and prepare for smoothing towards the new Y position. And I'm doing the same thing here in the snap up to stairs check, calling the save camera pose for smoothing right before I set the global position of the player, which is going to be snapping them up the stairs. And then if you just call this at the end of your physics process every frame, after any stair snapping has been done with the delta parameter, that is all you need to do, and all the camera smoothing should be working now, and you should get a really buttery smooth up and down stair stepping. And here is our final result. I'm pretty happy with this. After trying a couple methods, this was the best one I found, and I like this. It seems pretty robust. It doesn't seem to glitch out much, and it's really nice and smooth. And that is the end of the tutorial. Everything's all done. Of course, this method also works on like ramps and stuff. This method, unlike the other separation ray one, it's going to respect your max floor angle. You're not just going to be able to walk up walls easily. And yeah, it works on ramps as well. You're not going to have any issues with ramps either. So this is like a robust method that makes sure your character can walk on sloped surfaces or anything like step-like. And one thing I will quickly mention, I didn't cover smoothing the actual player model. So if you looked at this in third person, the stepping on the stairs might still look jittery. And for this, I would just suggest like an animation solution or like a visual solution of similar to how we have the camera lagging behind it. I would have the player model lagging behind it. Because yeah, it's hard enough to get just like perfect stair stepping physics working and not being glitchy. So I think any more smoothing should just be done visually. And yeah, that's the end of the tutorial. Stay tuned for more. I plan on covering various other features that you might want in an FPS character controller. Thanks for watching, and rate, comment, subscribe.